Hello everyone, welcome back to the very new chapter which we are going to start up, and that is the SDRs. And in this complete web series, we'll be talking about the software-defined radios and how this particular technology used to work, and we'll be deep diving into the RFIDs, and moreover, we'll be seeing like practical examples of how we can penetrate and how we can test up and what all other security breaches happened, and we'll be dealing with the different case studies. And after that we'll be seeing live examples, and we'll be doing the hands-on on this particular uh, devices and the technology. So let us start with this. So the first chapter will be starting off with the introduction to SDRs, or the introduction to software defined radios. So before we start with an SDR, let us just recall those days when we used to have the small set of radio in our houses, and we used to play songs, or we used to have AM amplitude modulations, and also we can grab up things, catch up the air, and listen to the broadcast happening from the radio station. So that was the means earlier technologies, and then we came over suddenly to the FM, in which we have a particular defined bandwidth, or the particular defined spectrum, in which we can publish the things, and we can tune to different radio stations, and we can listen to various songs, and we can just go with it. And then means so this was again the limited frequency band which has been provided, and means in which our radios can tune up with. So that was the basically the analog part of this particular, the FM radios which we used to listen in our cars, or in our day-to-day life. But if we talk about the SDR, so this is the software-defined radios in which we can listen to the entire spectrum, the entire band, in which we don't have any limit up to this particular frequency. We can work around with any of the frequencies which is floating around the air. We can sniff up the layers, and we can go and listen to any of the frequency. And apart from this, we have like different sets of hardwares which will be requiring for this. Like if we talk about a general radio which is fitted up in our cars, so that will be tuned up to, like, it has a certain limit of the frequencies to which it can be tuned up. Suppose I want to listen to the ham radios which is used by the cops, means I cannot tune that particular radio to listen to up to that frequency, or the narrow band. If I listen to want to if I want to listen to the narrow bands, or if I want to listen to some other protocols, I cannot go with that. So that is the basic limitation of the normal radio. So to overcome this limitation, we come up with an SDR. So that is the software defined radios, which typically listen to the entire spectrum in the air, and then it will be providing us the digital content, or the digital data. It will be modulating whatever the analog traffic which is floating around the air, and it will be converting it into the digital medium, and it will be displaying to us with the help of the specifically designed drivers, the softwares, and all. So this is basic functionality of the SDR. So it's not mandatory, like it's been limited to a specific purpose, like we can listen to the ham radios, or we can listen to anything. So there are certain means high-end SDRs which we can do multiple things, like we can listen up to the RFID tags, we can listen up to the other things also, like let's say the RF signals of our car keys and all. So there is no pre-convinced notion of the purpose for this particular SDRs. So basically, it requires the real-time processing, and various software packages and the add-ons were used to listen to different frequencies and the channels. So it is just basically the multi-purpose tools, and it means. if we talk about the tool sets which we'll be using in this entire series, will be dealing with different type of SDRs, and we'll be dealing up with the different types of tools which we can club up and listen to the multiple frequencies. We can listen up to the GSM channels, and we will be decoding up the IMSI codes, and multiple things we'll be doing in the coming future in this particular series. So, if we talk about SDR, it is hugely flexible but requires a lot of work to do. So, this basically defines the entire structure, or you can say the circuit diagram of an SDR, how it is being used, a simple SDR. So, it's basically the monoband SDR transceiver, that is Genesis G40. So, there are different things like we have the monoband, we have the high frequency SDRs, we have the transceivers, and then we have like half duplex, and then we have the full duplex things in which. Eh, so if we talk about the half duplex and the full duplex, in which we can do the broadcast and the receiving, but one at a single time. That is meant by the half duplex. But in the full duplex, we can do both the things simultaneously at the same time. So there are different things which we can do. So this is basically the generic diagram of an SDR, where we have an antenna connected to an RF front end, and then we have analog to digital converter and digital to analog converter, and then we are going up with an FPGA, and then we are connecting it with a USB controller, and then finally with the PC hardware, and then the TX and the RX power slots which we are dealing with. Okay, so FPGA and the analog to digital and the digital to analog plays a major role in this, where we have the field programmable gateways, and means that is basically the integrated circuit which can be configured by the customer. Means these are not pre-configured as compared to traditional radios. So means everything is controlled by a software configure in which we can configure different type of frequencies and different type of band in that. So depending upon the platform, the count and the combination of the analog to digital converters and the digital to analog converter will differ. So if we talk about the very small and the cheap SDR, there will be less, and if we talk about the high-end professional like USRP and all, there will be more in that case. So now we come up to the choosing an SDR. So there are lots of options which are available. Either you can do it by yourself, and so means basically if you want to test something, then you can go and start up with the cheap SDRs, and if you want to do it some robust thing out of it, so you can go up with an high-end SDRs such as your USRP, the Blade RF, and all. So if we talk about the low-end SDRs, the minimum you can spend around $10, and you can get an SDR, which is your RTL SDR. So in this course, we'll be dealing with RTL SDR majorly, and then if you want to go some more advanced features, you can go up with an high RF or the Lime SDRs, and then if you want to go up with an extreme SDR, then you can go up with the USRP and the Blade RF. So these are majorly the popular SDRs which are available in the market. Okay, so basically this is our RTL SDR which is available. So down the black color one you can see is the earlier with the CRC9 port for the antenna, and then the above one with the metallic covering, and they provide the heatsink in that. So with an SMA connector for the antenna. So this one is basically you will get it for 20 to $35, and it's basically the half duplex working on 24 megahertz to 1.7 gigahertz commonly bandwidth, which you can listen up, and So it's basically the closed source hardware. It's basically meant for the TVs and means just like a TV tuner, and but it has a certain chipset which can be controlled to and tuned to different frequencies, so that means we can do to different frequencies and we can listen to the air. So this one is basically your Rtl Sdr, and this one you can get it. The chipset is the same inside it. They all are using the RTL chipset inside it, and you can easily get it and start using it. So that, and if we talk about the functionality of both the devices will be same. The only thing which we need to take care of the drivers, we need to put up the custom drivers to support the frequency tuning, and we can listen up to the entire spectrum. Okay, so the tool sets which we'll be using is GQRX. It means this is basically one of the tool which can be used to program our SDR, and supports multiple platforms. So means we can use it either in Windows 10 or Linux or OS X or anyone, and it basically provide you the real-time display with an historic waterfall display, and lot of plugins are supported in this. And even you can do the recordings, and even you can take up the means set it up on a remote server, and you can take up the control via UDP streaming you can do, and you can listen up. I haven't tried this, but means it supports, but we'll be trying up this thing. So before continuing, you can see this is the particular thing of our device. So this is the GQRX which you are seeing up the waterfall model. So basically, we can tune up to multiple frequencies from here, and you can see the dark yellow lines, which you can see the data is floating around. So here something is going on. We can listen up to that, and we can even do the recording, and we can play it later and all. So sometimes the ham radio signals like this, which recently went off, and you can see up over here also some of the ham radio signals which are floating around, and some people must be talking. So we can listen up to that, and even we can tune up to more, and also we can tune up to GSM frequencies. So this is basically the overview. In the later we'll be dealing up with more things in that. So I have connected basically my SDR to virtual machine, and so it is basically my RTL 2838 UHIDR. So this is the thing which I have shown you in the slide earlier. So this is my DVB FM tuner. So it means it is using the same chipset as in the RTL SDR. So I've tuned up, and we can listen to the entire frequency range. So this is basically the overview of the GQRX. So in the later video, we'll be dealing up like how we can set it up, and in the different platforms. So basically, this is the view where we can set up the frequency, and this is the FFT graph which you can see, and these are the plugins which are available. And this is the waterfall diagram, and here we have the console in which we can record and play, and even we can go up with the UDP session for this particular GQRX. So basically, if you want to start any project of SDL things, we do not need to start from the scratch. There are a lot of projects which are available freely, and we can use those, and we can try to listen up to various protocols over the air. So one of the protocol which I want to discuss is ADS-B. So ADS-B is one of the protocol which is used by the ATS, that is your air traffic controllers, to transmit the data. So to transmit this means the transponder which are there in the aircraft, they used to transmit this data and just it's in clear text protocol in which we can listen up to that, and we can see like how much height the aircraft is, and what is the serial number of that aircraft, and what is the altitude, and what's the speed, and how from where to where it is going, and all the basic data means we can grab out of it. So, and another thing is why this ADS-B protocol is used. So this particular protocol is used by the autopilots. So when an aircraft is sent to an autopilot, this ADS-B transponder is used to transmit the data and to the other nearby aircraft so that they can automatically adjust their altitude and the flight direction and all, so as to avoid the collision. So this is one of the thing which means anyone can use it. Now the thing is, the details which it will show is already available, and it is already displayed in major of the airports and even in the online. In online various of the portals to display these sites. So what is the use and what is the like my bug in this particular thing is if we can see up this live data coming up from the aircraft, and so we can even transfer means even we can broadcast our data also, and we can generate a fake aircraft over the air, and we can like means if a malicious attacker is there, he can do anything like the collision and all. So it has been earlier demonstrated in the DEFCON 13 DEFCON version by Christian double zero by it has been demonstrated earlier by Christian in DEFCON 17, and he used to demonstrate the broadcast of the ADS-B packet, and he, in a very simulated environment, he just created a fake aircraft on the air, which is very much dangerous in this case. So this is one of the thing. If you want to see means after this, I'll be displaying a particular video in which we will be seeing like in the real time how it can be done, and the traffic and the monitoring. And apart from this, what else we can do is like we can even track the satellites which are available, either the geostationary satellites or means non-geostationary satellites which are there revolving around the Earth, and we can track those signals. We can get the basic details of those satellites, and we can means we can do much more things in that we'll be discussing later. So this is one of the thing which can be done. And if you talk about the po- posage and the flex interception and the decoding. So basically, these particular protocols were used in the old school devices such as your pagers, the beepers, or the pages in which an unencrypted broadcast traffic is there, and we can easily listen up to that traffic and we can decode that traffic. So this is one of the thing, but it is highly illegal to do that. So before doing it, means I won't recommend this to do, but it is highly legal, means highly illegal. So for the testing purpose, in the upcoming videos, we can see that some of the pages we can set it up locally, and we'll try to decode that. Now, if we talk about the RTL FM, the Multimon NG, so in which what we can do is uh, we can intercept a lot of sensitive data like your error message, IP, email address, and much more things in this. So what we can do is we can launch a phishing campaign or something. And I forgot to tell you, even we can broadcast our own FM station, and we can just yeah, up to a certain vicinity we can broadcast, and means we can tune up our station. So let's suppose somebody is using, let's say, 92.7 FM, so we can just simply on the same frequency we can start broadcasting our own song or something, so that the radios or the hard-coded radios available in the vicinity can connect to that frequency and will be able to listen our songs. So this is one of the things which can be done in this case. Now for IMSI cacher and the detector, so what we can do is we can start up our own base station also. So, but to do this, we'll be using the high-end SDRs like your USRP or the Blade RF and all. So in this, what we'll be doing up instead of listening to the air, what we'll be doing is we'll be start broadcasting our own GSM packet to the air and the connected the devices which are already connected to the base stations. They'll be start just like the evil twin attack, and which we can do it in the wireless hacking. The same can be done over here. So we'll be creating a fake access point sort of thing, which we call it the base station, and the people will be start connecting to that, and we can steal the relevant information from that. Now another tool which we'll be using for the RTL SDR is the calibrate. So it is basically used for frequency drifting. So if you want to listen to a particular channel from a certain frequency, we can do that, and we can provide the relevant amount of power to our device, and we can start listening to that. And another thing is the custom. Custom is basically the calibrate adds power cutoff detection, which add the speed by limiting the detection edges. So this also can be done, and we'll be seeing up in the upcoming videos how we'll be doing this. So in this, what we'll be doing is we'll be scanning up on a specific channel and up to a limited frequency range, and we'll be seeing like how what all things are available in that particular vicinity or the attack surface. Now, if you talk about the web SDR, so web SDRs are also available in which we means a single SDR which has been set up and or the multiple SDR which has been set up and provided up over the web so that the community and the testers can use it and check out the functionality of those. So this also you can check out, and those who want to get in hands on, they can go up with the websdr.org and they can check out like with the web SDR and how means what is the look and feel with that. So web SDR connected to the internet with a high speed bandwidth and the massive SDR bandwidth. So it has the multiplayer support tuning with a web-enabled waterfall display. So this all you can see up with over the web. It's the same SDR which is there. Only the display has been showed up in a single page, a single web page. So this you can go up and practice. Means you can get in hands on. There are a lot of web SDRs which are available free of cost. So which you can search out over any of the search engines. So and you can find many of them. And we have the Multimon NG and the Sorcerer for Windows for piping out to the other decoders if the decodings are there. If the encodings are there, like we can go up with the LSB, the AM/FM, and all. Now, if we conclude this particular session, the SDR platform is a complex with many more tools, but inexpensive option exists. And virtualization is key for initial discovering of the signal and a lot of fun. So basically we can virtualize multiple things even in the Kali and even in the other platforms. You can install the tools and we can start using our SDRs. So many existing projects can reveal deficiencies in the protocols, like as I told you the ADSB which is there, ADSB in which means multiple things can be performed, and even in the upcoming video we'll be showing like after this slide I'll be showing you a video in which we'll be seeing like how we can decode the ADSB and how we can decode the satellite, and we can see the basic relevant information, and means how an attacker can use that particular information to gather its attack surface. So, well, that's all for this video. Let's come up to the video and see the live example of that. As you can see that we are just getting the flight information, and you can see that the flight is moving. So this is the live information which we are getting from the ATC directly, and here you can see various flights. As we are having a small antenna, so we cannot sniff much ahead, but we can easily get that. So these are the live information which we are getting. As you can see that we are getting the speed and the height and the distance of that particular flight, and these all are the three flight which is moving from RGCIA. So this is how we can just sniff out the basic data of the satellites which is revolving around the earth. As you can see that there are various satellites, so since I am sitting inside, so we are not able to capture that much signal from a small antenna of 5 dBi. And so if you can see that still we are getting the two satellites. If you can see the name of the satellite and the operational status, we are not getting it clearly due to the signal issues, and other things like the epoch time and the eccentricity and everything will be getting, which is broadcasted and being received on the land. And here is the other one which we are getting, that is F029, and you can see the transponder details also, which is broadcasting these details. So on this particular frequency we are just sniffing, and from there only we are getting the beacons. So, well, that's all for this session. Thank you. Thanks a lot. Stay tuned with me, and we'll be soon coming up with the more in depth session of the SDRs.